All right. All right, let's start, I think. Hello everyone. Bonjour à tout le monde. Mon français n'est pas trop bien à faire cette présentation en français, donc je vais changer à l'anglais. Yeah, welcome again. My name is Axel Morgner from Frankfurt in Germany. I'm co-founder and CEO of Structr. And yeah, I'm happy to give you a presentation presentation about Structr. So I have to walk over there. So I hope to avoid that feedback loop. So let's see. Can you switch to my computer? Cool. I'll try to give you a live demo, so I will do it from my own computer. All right, looks better. Okay, now here you can also read my name. Yeah, if anything stays unclear after this presentation, please come to our booth. And also tomorrow at 2 o'clock, there's a live coding session where I will do some experimental live coding on stage together with my brother, also co-founder Christian. Yeah, welcome again to everyone. You didn't miss anything right now. So first of all, the question most of you are probably here for is, what is Structr? Structr, we call it a low-code platform optimized for complex use cases. And that's the most important, I think, message, or I have two messages here. So I will come to the two messages later. So our company is based in Frankfurt, Germany. We're around for like 12 years now, so we're not really a startup. We are still small, and we like to be small. We're not really motivated by growing that much. But we love to do projects and we love to make our customers happy. So our motivation is technical reasons and for the love of doing software projects and building something that makes sense to our customers and to the world. Yeah, as I said, founded in 2011 by my brother Christian and me. We are headquartered in Frankfurt, mine, and we have a couple of German-speaking and also international customers. And we're still completely owned by the team and friends, so we're profitable from the start. And I could now tell you a story about each of these projects, each of these customers. They have all the projects have one thing in common. And I want to start with that. The world is complex, we all know that. It becomes more and more complex, I think. Probably you also have the same impression that complexity is rising and growing everywhere. More and more things to manage, more and more things to consider, more and more content, assets have to be taken care of and managed in a digital world. So we humans tend to create digital solutions, digitalize everything. So the complexity in software development and projects in the IT industry is growing. And one key message about Structr and why we are here is that you can handle much more complexity with our platform than with any other no-code or low-code tool. That's our claim, and I will try to prove it, or at least make you understand why I'm happy saying that. So these curves, don't think that I have to explain it to you. It's basic maths. We have a linear curve and two exponentially growing curves. And you see after a certain time, the exponential growth will of course overtake the linear curve. So that means that in one way or the other, exponential growth can kill you. We all know what that means. We have had the pandemic a couple of years ago, and The same can happen to software projects. Complexity can kill software projects. And a lot of software projects and development projects fail because of the complexity. So let me start with what I mean by complexity. I give you 4 examples now of customer projects we did for various companies. One is Plan One. Plan One is a subsidiary of Schuko. I don't know if you know Schuko. It's one of the market leaders in metal window and door frames. So they are very common in Germany. I think in Germany they are market leader, and it's a big manufacturer of metal frames for houses. And Plan One is the digital department of Schuko, and they had the task or the challenge to build a marketplace or an online catalog for building products, for architects, for construction project managers, but not only for the Schuko products. I mean, they were 100% subsidiary of Schuko and they were paid by Schuko, but they had the chance to build a marketplace for all their competitors' products. The problem was, only the small problem was that all the product catalogs have a different format, different data model, different attributes, different naming. And they wanted to put that all into one big database to be able or to enable their customers to make a comparison over all the products for a certain purpose or with a certain size or a certain specification over all the products of different vendors and suppliers. And the data model to manage this metadata was so complex that they found a graph database, and we implemented that with our technology. Next one is different, but somewhat similar industry. It's a manufacturer of yachts in South Africa. They are building super yachts, like 10 to 25 million euros in South Africa. They're one of the biggest employers in Cape Town. It's Italian design, European technology, and cheap labor costs in South Africa. So that's their business model. And they're building, like, I don't know, 1 up to 3 yachts per year. It takes like 3 to 5 years. And it's so complex because they are custom made. And people who are able to afford these yachts, they have lots of special requirements. And you can imagine that they have to take care and keep track of all the requirements and the questions from the future owners. And they tend to, or they used to, manage all this information in Excel sheets. And there was basically one person responsible for managing all this complexity. And they kind of had some issues and problems. Basically, they sometimes just missed something, and they built maybe the wrong material into the boat. But when it was delivered, it was already too late. So it was kind of difficult situation. And together with us, we migrated, I think, up to like 10 to 15 Excel sheets into one common database. And all the data now is managed with one system. And they didn't found any other supplier, came to us, and we solved the problem. Next is compliance and risk management. A company that does risk analysis and know your customer analysis for a couple of customers, primarily in the property management and also sports betting industry. So they have to manage a big network of people and companies and all the documents which store information about the companies, how they are related to each other and to the people. A big, complex network of information. And that's also a good example with a very high complexity. And with this system we built for them, you can do real-time reports on hundreds of different attributes and pieces of information, which was not possible to do in any other technology. Last example is a very small customer. It's a holiday architecture. It's a very special little company. They are renting special and unique holiday residences. And they were not happy with all the booking systems, the commercial off-the-shelf booking systems like Booking.com and so on, because it was either too expensive because they had to buy the whole stack or the whole package, or it was not flexible enough if they just stayed with a smaller tier. So they asked us, with a very limited budget, can you build this? And we built a quite complex system in a relatively short time. So complexity is not only important or relevant on the bigger scales, but also on the smaller scales, because complexity also can mean that you have to pay a lot to get exactly what you want. So to be flexible also requires to be able to manage the complexity. So the world is complex. Only 4 examples. Could go on for hours with this. And second message, what's special about Structr? Structr is built on a native graph database, namely Neo4j. Maybe some of you have already heard it. Yeah, Neo4j is the market leader in graph databases. They are around from, I don't know, 2010 or something. That was, I think, when version 1.0 was released. So technical infrastructure is very simple. It's basically a graph database where we store not only the domain data, so the customer data, but also the parts of the software application. We access through the Structr backend, we access the database. The Structr backend also is, of course, the kind of server for all the components in the Structr platform. Then we ship together with the backend a couple of front-end tools. That's our administration toolset or admin suite, where you have something like a schema editor, a front-end application builder. There's even a file system in the graph database where you store the metadata of all your folder hierarchies and files, and a lot of stuff around that. And using these tools, we, our customers or our partners, are able to build customer apps. Big variety of different industries, so we're not specialized in any industry or any special type of application. So you have 100% degree of freedom in what you're doing with Structr. And also, you can, of course, connect other apps to various APIs. So there are a lot of APIs. It's a completely open platform, extensible in any direction. And yeah, if you want to learn more about the technical details, please just come to our booth. We can answer hopefully all of your questions, from the business questions up to the technical questions. So the main developers are here today. So just a short excursion to what graphs are, because I mentioned already the word graphs. This is the city of Königsberg, and Königsberg is separated by a river into 7 districts. And you can go across bridges. In fact, there are 7 bridges, so this is the conundrum of the 7 bridges of Königsberg. Probably already heard of. So that, and back in the 18th century, there was the question: Can I visit all the districts without ever going twice over the same bridge? That was a problem that no one could solve. So then there was a mathematician called Leonhard Euler. He did an abstraction. So he drew a map. I think it's an original sketch or original map. And what he did was he already abstracted away everything that was not relevant for solving that problem. So he named the districts A, B, C, and D. And then next, he just put them or reduced them to single dots and connected them by lines, and all the lines, each line represents a possible way to go over one bridge to another district. And that was the birth of the graph theory, which he was kind of the inventor of. And using graph theory, he was able to solve this problem. And this is a nice equivalent of the 18th century in 1736 how you can solve a lot of complex problems when you just abstract them and think in graphs. And we're still doing that. I mean, Euler did that in 1736, and we are still doing that 250 years later. Like in the 17th, last century, entity relationship models are graphs. UML was invented around 1990. Also graphs. RDF, Resource Description Framework, all the knowledge theory or knowledge management systems are based on that, was invented in the 2000s. So the mind model to think in connected things is very common. So back like 2007, I think, Neo4j kind of, they were not the only ones, but they were very, very early. They kind of invented the property graph model, which is a database graph model that just takes what Euler has thought out into an abstract model. Like the dots are nodes, so-called nodes, and the arrows are relationships. All these nodes and relationships also can have attributes, like how you would store data in the row of a table. And so they called it a property graph model and implemented something they called a graph database. You probably might wonder why I'm just keep writing native graph database. There are a couple of vendors who also have graph databases, but they're storing the actual data on the physical layer in kind of like relational database or key value store. And that's a translation happens when you store and retrieve the data, which kind of destroys all the benefits of the native graph database, which is optimized down to the physical layer. And now in the native graph database, you can store all these data without the so-called impedance mismatch. So it's just a natural mapping between your abstract data model and the physical database. So that's the kind of technical explanation. And the benefits are very big, because when you're now doing a query, you can just follow the relationships in your graph. You don't have to compute your connections. So you don't have to do join operations as you have to do in a relational database, or you don't have to do map reduce like you would have to do in key value stores to create an aggregation based on various filtering or combination parameters. So that gives you exactly what we have seen in the graph or in the diagram. There's a very interesting kind of pun, or people in the graph industry, they always wonder why people are calling a diagram a graph. But of course, here it's, like we saw in the graph, the exponential growth of the query time you need in a relational database is just killing projects, basically. If your project is too complex, of course you can cut it down in parts, and then you have maybe a microservices architecture, but once you have too many different service APIs, you have the complexity, or you have the kind of explosion of this exponential growth in the number of relationships between your services. It grows also by n to the power of 2. And no wonder that the graph data model is the most popular over the last 10 years. So this is a picture taken from dbengines.com. It's updated regularly. You can look it up. I think it's from like this week. And even though that there are many newcomers in the past years, like vector databases, time series, and so on, the graph database model is still the most popular amongst all database models. And this is also the reason why it's very popular. Because graph technology makes a difference. This is another picture. It's taken from the Gaping Void group. It's a kind of design group, and they creating very nice, nice illustrations, and they just observed that if you're taking data points and put some labels on them, you get information, transformation from data to information. If you connect them, you get something like knowledge. Traditional databases store information with labels. You put rows in a table. It's basically, it's that what you're doing here. Graph databases, they connect the data. And this is a big step. But when you're now using applications, I don't know if you can see it here, you're asking questions. How is this node connected to this node? What are the possible paths? How long is that path? And so on. And you get insight. When you are able to store that information, maybe create another relationship, a direct relationship, you create additional knowledge or wisdom, is how they call it. And now, then if you're using that information to make a difference, then you create impact. That's what we want to do with graph technology. So this is basically the mission statement of graph technology, to really make a difference by technology. And this is the nice picture of the graph technology landscape. It's a selection, it's from, I think, 2020. It's an overview of all the companies that have already a product or built something in the graph industry. And here it's difficult to see. There are all the graph databases, and you have already companies like Microsoft, AWS, I think IBM also has created a graph database. A lot of newcomers like TigerGraph and whatnot. And also, of course, Oracle has a graph database, and also the market leader Neo4j. And most of the Fortune 500 companies have already adopted graph technology. It's a very big market already. Like most of the big names, and the market leader Neo4j, they have gotten an investment, I think, 2 years ago, and they are now the most valuable privately owned database company in the world, valued at $2 billion US. So it's a very interesting success story for that company, and they're only building a graph database. So how does Structr stand out? So we're building on top of and using Neo4j. Structr is the only low-code system, and that is what is the main differentiator and the main uniqueness point of what makes us unique. Stores all relevant parts of the software application in the graph database. So all we do when we create a page in our application, or when a process or a program is running, it takes data from the graph database and creates the necessary components in real time from the graph. Structr is not optimized for any purpose, so it's very, very flexible and customizable. So this is where our efforts go in. And we're not creating a special kind of like workflow management or ERP or CRM product. We have a technical, a kind of horizontal platform which is open to any use case. We provide that in the form of an integrated, modular, all-in-one tech stack. You don't need any additional components, and it's scalable. And most of the kind of marketing terms and marketing promises all the other no-code or low-code vendors use, they also apply to us. So I will not bore you with all the marketing stuff that anyone else tells you. We think that as we focus on developers, on kind of like pro developers also, and not necessarily on the citizen developers, so we're not providing a no-code tool. It's not like you can use that tool to like click, drag and drop and build all the solutions you want. But we're really focusing on enabling developers to just overcome the limits of complexity in their projects. So we think that just frees up and saves time that you can use for creativity and communication. In the new version 5 of Structr, we have added some more components, some interesting components. So we started with using the graph for mapping the schema, the data model implementation to the graph. That was the first iteration. After that, we created a front-end builder, where you can see here, maybe you can see it. We are storing the entire document object model, or the page tree, or the tree, all the trees of the components that make up a page in the graph also. So the whole front end is rendered in real time directly from the graph database. That means that you don't need any caching, for example, even for complex websites. And even if you have a complex permission model. So imagine that some components, some subtrees here in your page are visible only to a limited number of users or groups. You cannot really cache that information. So think you probably have also already built some web applications or used the content management system. Think about switching off the cache in the WordPress system. WordPress is a wonderful system, but it uses a relational database in the backend. And if you switch off the cache, all the information or all the pages have to be assembled in real time. And that means a lot of database activity, and it's just slow. It takes for a complex website to be rendered without caching in WordPress takes like minutes. We don't need that in Structr because querying the database and just following the connections between the elements, how they are stored in the graph, is just so quick that you can do complex websites in real time, like sub-seconds or even sub-milliseconds. So that was the second part in Structr, and then we added some additional components like a flow engine, a flow editor. I can demo that tomorrow or if you come to our booth. And now in the new version, we added or we connected the front end to the back-end logic. So we created a data model and an implementation and tools for storing the event action mapping in your front-end application in the graph. So, for example, if you now click on a button, create new project here in this example, then the information, what should happen in the database or in the system, is stored in the graph. And this gives you also new opportunities to not only use that information to build sophisticated web applications, but also to visualize the entire path of what's happening in your front end and what's happening in your back end. So this kind of visualization will be coming in one of the next major versions, and that will I think will give you a completely different and new user interface to application building. So now I can try to show you that. So it's a little bit difficult with a handheld microphone, and let's see how the demo gods are today. If that doesn't work, there's a demo session tomorrow at 2, or you can come to our booth. But before we go to the demo, any questions up to now? So maybe it's the best time to answer some questions now. Take the mic, please.
I have a non-technical background, although I saw that you put in the description something about R, the language. So, and I have used that before. And also, I was just very curious, how is this different from GraphQL?
Okay, good questions. So R, yeah, right. So this is also probably something we can better show at our booth or maybe in the live coding session tomorrow. So R is one of the supported languages that you can use in Structr when you're creating or doing scripts, creating scripts. So Structr is using, internally is using, or is built on a kind of new virtual, not Java virtual machine. So this is the runtime environment where all the code is executed and translated into bytecode and executed against the database or whatever. So the new GraalVM, it's something that a group within Oracle has created over the past couple of years. They feature something called a polyglot engine, polyglot scripting engine. That means that they translate almost any supported language into bytecode. So in the past, Java virtual machines only were able to translate Java code into bytecode. And this GraalVM can translate JavaScript, Java, PHP, Python, R, C#, even Visual Basic, if you still want to code in Visual Basic, and whatnot. So that's very interesting, and we support this architecture. That means that wherever you put script code in the platform, so remember, Structr is not a no-code platform, so you still have to, or you can, depending on the perspective you have. Developers love to code. They just want to code, and so we don't take them away this possibility. But you can do it they can do it in their preferred language. So for example, for R, of course, it's very interesting because you can do statistics in a very nice way. And you can directly from R, using this kind of generic interface, access data in the graph database. And if you have an interesting and complex use case, maybe let's talk. And the second question, how does it compare, or how is it different from GraphQL? So it's interesting because they get this question a lot. GraphQL has not really something to do with graphs, even though it's called GraphQL. GraphQL is a query language which is used as on the same level, or maybe as an equivalent, or even a replacement for so-called RESTful queries, where you just query a kind of type resource. So, for example, in our demo project, we will implement an online store or shop. So you have products, for example. A REST query queries the interface or the API for products, and you can filter by product ID, name, size, whatever. But you cannot really query on deeper levels, like give me all the products that are in a category that is also connected to other products that have been bought by customers that are not older than 80 years and from France. Yeah. So that is a very complex path in your query, and you cannot really express that with a simple RESTful query. But you can express that query, which looks like a graph, in GraphQL, for example. So that's the reason why I think the developers called it GraphQL. So it's graph query language. And to add a little bit more to the confusion, there's a standardization process ongoing to call the language that applications communicate with a graph database, to call that graph query language, graph GQL, right, GQL. So there's GQL, which also stands for graph query language, like an equivalent to SQL, SQL, and then there's GraphQL. So once this standard is out, that will be very interesting to see what happens. All right. It's a very long answer. Sorry. There were other questions?
This could be interesting for us as in special use cases as a system integrator. So I was very curious to do you work with partners? How much does the tool cost? What the pricing module you have for the partners? And also, what is the pricing of Neo for G? Because, for example, if you use MongoDB, for example, and you want to have it encrypted, it costs like 30,000 euros starters. So I'm very curious to the pricing model also for this kind of technology.
Yeah, thanks for the question. So maybe I start with your last question, so you can spend a lot of money also on Neo4j databases. So they have larger business tier that probably in the same price range if you need it. But good thing is there's a community edition that does most of the basic stuff you typically need for smaller projects, and if you don't need kind of high availability and clustering. So for smaller projects, Community Edition will do. Also, Structr has a kind of simplified edition. It's called also Community Edition, which is also free. Structr itself is completely open source, but we also offer, so our business model is also licensing. So, but it starts very small, and we are targeting the SMI market, I would say, or departments within big companies. So it scales with your requirements, and we have a value-based pricing. So if the value is very high for your company, of course we ask for a little bit more. If not, it's not that expensive. And compared to a document database, it's interesting because if you in a document database, you can store also complex data in form of like documents, like hierarchical data. But you have to decide between storing single pieces and then bring it all together at query time. Then you have the computing effort, or you have a lot of redundancy because you have to store the whole document as one big data object. And the graph is exactly in the middle, or it's the perfect combination of both models. You store your information as single entities. But you don't reference them by ID, which means you have to compute the logical connections at runtime, at access time, but you store the connections, the relationships between your single data objects at insert time. So you have the effort to get this aggregation is much lower because you just follow the paths and you just can assemble your complex documents at runtime. And typically in your application, typical applications are read-heavy. That means that most of the time is spent on reading data from the database and not writing to it. So for example, graph databases are not very good at, or tend to be, it's not true anymore because they are optimized for like 10 years. But it's more effort to store something in a graph database because you have not only to append something to a table, but also make the connections. But if you have an interesting use case, yeah, let's talk later. Over there, here's Jeff from our sales department, so he can answer all the business questions as well. Some more questions before we try the demo? I think I have a couple of minutes more time to show you the product. Let's see. Unless you have more questions, then just raise your hands. So this is the user interface of Structr. It's all web-based. It's an integrated platform. I've already created the use case for tomorrow. It's not 100% perfect now and finished. And also we will, of course, tomorrow, we will enhance it and add more functionality. The most important functionality or the most important parts of the user interface typically start with a schema. So here you have a schema editor, which already looks like a graph, and it is also a graph. I've already created some data types in it. For example, a product. So the use case is an online store. It's a completely working, functioning online store with payment interface. And I've built the core of this, as you can see here, in about like 2 days from scratch. So creating new data types is easy as, let's say we want to add some customers. So then we just enter customer as the data type we want to create. Click on create. Now the schema is compiling. That means that we add another node or an additional node with the name customer to our schema graph, and it's translated into working bytecode, and this bytecode is inserted into the running Java virtual machine, which basically means now we have a database for customers. I can go to the data section, find the customer data type which was just created, and I can add customers. I mean, that's probably, we would call it no code, because I didn't really code something. If I want to can now connect customers to, let's say, orders, so we have, that was already at the right place, sorry. We have the order type already created. We can just connect customer to order, tell the system, because we are thinking in graphs, how these connections should be named. It's more or less an internal information, but let's use something that makes sense, like customer has orders, and now we have to think about the cardinality. So what is the kind of multiplicity of connections? So typically, multiple customers have multiple orders. I think that's a good assumption. So let's put it that way, and we can rename that here just to make it a little bit more readable. So customers have orders. And now we have created a completely new database, which connects to the existing database. And now we could go on and connect. Oh, we don't have any orders, so let's create some orders and assign orders to customers. Simple as that. So now we have already created a graph, simple graph, and we have extended the schema. You can, of course, create properties like string properties, numbers, dates, and so on. So it's a complete development environment for, yeah, as I said, complex software applications. So this is one part. This is one part, it's the schema. And you can think of, I mean, if you want to extend the use case, you can just go on like that, and after like an hour or so, you just have to create it like 3, 4, 5 additional data types and have connected them in the right way with the right semantics. And that's all you have to do. And now you can go to back to the front end and then wire it all together. What we already did is create pages, for example, for products. So please excuse the bad images. We will probably improve the images for the demo tomorrow. And what we have, let me show the products page. So this is the preview. This is the rendered output. This could go into production, and it will happily serve 1,000 customers per minute. And sorry, I have to move it a little bit. So this products page just uses a so-called repeater. And in this repeater, maybe probably a bit small, in this repeater we are using scripting code. We don't have to use scripting code. We could also use a flow with a database query, but in this case, it's just a find query. And this query could be in any language. In this case, it's JavaScript, because most of the front-end developers already know JavaScript, so we just let them use JavaScript in the back-end as well. And all this subtree of your page will be repeated for each result of this query. And this database query could be a flow, as I said. We'll show you tomorrow in the demo, or if you come to our booth, I can demonstrate that. It could also be Cypher. Cypher is the database-specific query language of Neo4j. With Neo4j, with Cypher, you can do very, very complex graph queries, like finding a special path through a very complex set of data. So this is what in the more complex projects is done more often than using these simple queries. But everything is stored in the graph, and maybe also interesting, the file system. So also all of your files and folders can be stored in a graph database. Let's see, here we have some images, some product images. The metadata is stored in the graph database, and the binary data can be stored in any place which is accessible over a file protocol. It could be a local directory on your server, it could be any cloud storage, and so on. So you can, if you're thinking about creating a document management platform with custom metadata, very simple. Because, maybe as a last feature to end with, you can also extend existing data types. For example, if you want to create a special invoice document. Let's call it invoice. Now it's just it's an empty type. It's new, it only has some default attributes like name, a UUID, some date attributes. But it becomes, of course, interesting if you say, okay, this invoice is also a document. So I just extend the document class, or the file class, sorry, file class. So document is already application specific. So I just use type inheritance, as you know it from other developing or languages or programming languages. So now our invoice is a file. Let's also make this file and folder data type visible. And then you see the inheritance relationships. Here's also image. So here you see invoice inherits from file, and also image inherits from file. And now you can, in your file system, create objects of the type invoice. And out of a sudden, all these invoice objects, they could store binary data, like, for example, an invoice PDF document, but they can also have custom attributes, as you define in the schema. And they are connected to, they could be connected to orders. So next step would be to connect an invoice to an order, and so on. And then it's very, very simple to get the customer name for your invoice, or the invoices for your customer. And in your front end, you just say at the right place in the front end, now I want to have a list of all the invoices for this customer in the customer profile page. It's just simple as defining it in a schema, doing the mapping, and use the data. And typically, one of our developers does 2 to 4 projects at a time. So that's also the reason why we are still small. So we have like 50 customers, and most projects were done by us ourselves. And we're just using the tools we've initially built for ourselves over the past 12 years. All right, that's it. If you have more questions, yeah, please come to our booth. I think it's B6. B6. Jeff is here for all your business questions, and the team at the booth also is happy to answer technical questions. Thank you very much.